So our next video is part 125. It's line 18A 3S4. Black hole SuperB INFN Belle 2 LHC CERN Electron Capture Wow Seti. There's the mathematical equation, and here's a picture of a black hole. Now here's the tags for this video. It's on black hole microstates, entropy, string, Wick rotation, SuperB, particles, neutrinos, CERN, Minkowski, Osterwalder-Schrader, electron capture, neutrinos, matter, Gilberto-Bernardini, muon, particles decay, SLAC National Accelerator Laboratory in Menlo Park, California, Belle experiment at the KEKB Accelerator in Tsukuba, Japan, Tor Vergata, Italy's National Institute for Nuclear Physics, INFN, Italian physicist Nicola Cabibbo build a theoretical model around the LHC's future discoveries, Large Hadron Collider LHC CERN, Europe's High Energy Physics Laboratory near Geneva, Switzerland, the Italian Institute of Technology in Genoa, Babar detector, LHC uses high energies to produce as yet unknown particles. SuperB will look for the indirect effects of those particles on the ones we already know. Japanese Belle 2 experiment, Petrozio, INFN, Gran Sasso Laboratories, and Virgo Gravitational Wave Observatory near Pisa. Those are the subjects in this video. Okay? So black hole. On the black hole microstates, a 1-hour presentation on the interpretation of black hole microstate counting using entanglement given at the High Energy Seminar UH Manoa Summer 2004. Entanglement interpretation of a black hole entropy and string theory, a 1-hour talk given at the ISCAP Seminar in Columbia University Summer of 2005. And black hole entropy, a 1-hour presentation on black hole entropy, its evaluation in string theory, and a possible interpretation as entanglement. And again, that was in 2005. It's physnet.bgu.ac.il. Okay, so entanglement interpretation of black hole entropy and string theory. I googled it some more to see what else came up. There's a paper here from Ram Brunstein, Martin B. Einhorn, and Amos Yarum. We show that the entropy resulting from the counting of microstates of non-extremal black holes using field theory duals of string theories can be interpreted as arising from entanglement. And you know what? I put that in the other video, and then somehow I got it on this video. Remember, I just did this in the last video. Why did I do that? Leave it to me, eh? Okay, we already discussed that in the last video. Google Wick rotation diagram. This is what I get when I work too late at night. Giancarlo Wick. Okay, in physics, Wick rotation, named after Giancarlo Wick, is a method of finding a solution to a mathematical problem in Minkowski space from a solution to a related problem in Euclidean space by means of a transformation that substitutes an imaginary number variable for a real number variable. This transformation is also used to find solutions to problems in quantum mechanics and other areas. And this is him here, Giancarlo Wick. That's what he looks like. Wick calculated the magnetic moment of the hydrogen molecule with group theory theoretical methods. He extended Fermi's theory of beta decay to positron emission and K capture. And he explained the relationship between the range of a force and the mass of its force carrier particle. He also worked on slowing down of neutrons in matter and joined a group of Italian physicists led by Gilberto Bernardini, which made the first measurement of the lifetime of the muon. And you remember we discussed muons before with neutrinos. And here's a diagram called electron capture. And there again the mathematical equation comes up. And then the first electron-positron collider comes up as a PDF file from Gilberto Bernardini. And it talks about him receiving a degree in Pisa in 1928. So this is quite old, this old PDF file. Then we got mathematical physics from Osterwalder-Schrader axioms, Whiteman axioms. Pelle E. T. Jorgensen, Jezer Olofsson. The mathematical axiom systems for quantum theory, field theory, grew out of Hilbert's sixth problem, that of stating the problems of quantum theory in precise mathematical terms. There have been several competing mathematical systems of axioms, and here we shall deal with those of A.S. Whiteman and K. Osterwalder and R. Schrader, stated in historical order. They are centered around group symmetry, relative to unitary representations of Lie groups in Hilbert space. We also mentioned how the Osterwalder-Schrader axioms have influenced the theory of unitary representations of groups. And this is what came up. So my thoughts on this, I did this on February 10th. I Googled Osterwalder-Schrader and found this paper, Mathematical Physics. It talks about mathematical systems of axioms. I know that keyword came up before. Axioms comes up in line 18F. Axiomatic formulations of thermodynamics under data to read. Hilbert is another keyword. It comes up in line 17I and 17 line index in line 16A. Hilbert plus Banach spaces in line 17I. Line 17I has linear topological space vector space Hilbert Banach Wow Seti. So we have quantum field theory plus axiomatic formulations of thermodynamics plus Hilbert spaces plus Banach spaces equals linear topological space plus vector space plus Hilbert series. So if you can make an equation out of that and see what you can come up with, I'd be really interested to hear from you to see if it means anything. See the data from line 16A, adding more here about Hilbert as a keyword, and then go to line 18AS5 video for more about the connections to this keyword. And of course, I haven't filmed it yet, so you're going to have to wait about a week or so. Okay? So SuperB will study how heavy particles called B mesons decay into the welter of other exotic particles. L. Taylor, T. Macaulay, V. Chikoka, C. Loreno, CERN. Okay. Various quotes to read, published online October 10, 2011. SuperB Particle Accelerator Project launches. Funding uncertainty could delay high-speed Italian development. The accelerator will be what physicists call a B factory, where electrons and their antiparticles, positrons, will race around two 1.3 kilometer long rings, then collide and produce heavy B mesons. By studying the way these particles decay, physicists hope to fill some of the gaps in the standard models of physics, such as why there is more matter than antimatter in the universe, and whether the exotic particles predicted by the theory of supersymmetry really exist. SuperB will produce 100 times more collision events each year than did the two B factories previously built. The Babar experiment at the SLAP National Accelerator Laboratory in Menlo Park, California, which shut down in April 2008, and the ongoing Belle experiment at the KEKB Accelerator in Tsukuba, Japan. This increased luminosity should allow researchers to study even the rarest of physical phenomena. Italy's National Institute for Nuclear Physics, INFN, is running the project. Under an agreement signed by the INFN and the Tor Vergata on Friday, the two will set up an international laboratory to oversee the construction and operation of SuperB. The lab will be named after Italian physicist Nicola Cabibbo. Roberto Prantozio, who will soon give up his post as president of the INFN to become Director General of the new laboratory, says that SuperB will complement the Large Hadron Collider, LHC, particle accelerator at CERN. Now that's the one they just did a test on the neutrinos and found that they travel faster than the speed of light. So this is very important because these two labs are going to be doing a lot of testing, and from their tests they'll be able to determine whether or not we can build a UFO that can go at 5G of force. That's what I'm assuming. Europe's High Energy Physics Laboratory near Geneva, Switzerland, by helping to build a theoretical model around the LHC's future discoveries. Whereas the LHC uses high energies to produce as yet unknown particles, See, they are creating unknown particles with this system. They don't know what they can do with these particles. But according to these formulas that are coming up in this Wow Seti signal, they can take those particles and use it to create an accelerator plasma, which can be used in the rocket engines, which can be used for this UFO engine. Okay? That's a mouthful, but that's what it means. SuperB will look for the indirect effects of those particles on the ones we already know, says Petrozio. The Italian Institute of Technology in Genoa is expected to join the collaboration within a few months. It will build cyclotron laboratories which will conduct microscopy using the high energy radiation produced by the accelerator. So I looked up all these different words to find out what these things mean. And then I pulled out the keywords from what I found, okay? United States, which plans to provide reusable components from the Babar detector. The Japanese Belle experiment, to be called Belle 2, work on which will begin next year. Construction of SuperB is expected to begin next year, and operations are scheduled to start in 2017. A breakneck timetable brought on by the completion with Belle 2, or competition with Belle 2. Now I don't think they should be competing with Belle 2. I think they should be working together as a team. That would be better for all of us. Although it will not reach SuperB's luminosity, the upgraded Japanese experiment is expected to start taking data in 2016. We'll probably be 1 year late, says Petronzio. Sorry, I apologize if I'm saying his name wrong. We can catch up because we will see many more collisions, but we cannot afford to be later than that. INFN activities include many other large-scale experiments such as neutrino and dark matter research at the Gran Sasso Laboratories, the Virgo Gravitational Wave Observatory near Pisa, and a strong involvement in LHC. February 10th, my thoughts. When I read about SuperB, I immediately thought of the testing for the neutrinos, non-gravity, matter, and rotating spaceship. Can they use the test results from SuperB with the formulas provided in the line Wow Seti equations to test the liquid gas plus the neutrinos? I remember writing about cooling the neutrinos to slow them down and see if they can split in half like an atom. They are particles. Do they all split? If not, why? What can we do to produce energy from these particles by mixing them with the gases mentioned in the Wow Seti solutions? Okay, so that's the end of that video. And we will go on to the next one now.